Okay, I welcome you to this topic on moment of a couple. Today we'll be starting with the moment of a couple. Before we start the moment of a couple, we need to define what we essentially mean by the couple. What is a couple? As far as the couple is concerned, we often encounter in our day-to-day life such physical phenomena which are acted upon by the forces which whose magnitude is same but whose directions are opposite. That is, if you have a system such that on a system we have the forces acting in the opposite direction, one force is acting in one direction and another force is acting in the another direction, such that the two forces are acting in the opposite direction, but the magnitude of the two forces is same. Whatever force is acting in this direction and equal amount of force is acting in the opposite direction, we say that these forces are terms as, we say this is a couple. We call this force as a couple. So this is what is written here. As far as the couple is concerned, you have two parallel forces that have the same magnitude but opposite direction and are separated by a perpendicular distance is called a couple. So as far as the couple is concerned, for example, look at this diagram. In this diagram, in this figure, we have two equal forces, force F and force F. Magnitude of the two forces is same, but they are acting in opposite direction. And in between the two forces, there is some perpendicular distance, okay? So two equal and opposite forces having perpendicular distance in between them constitutes a couple. So if we are asked to define a couple, what do we mean by couple? In a couple, we have two equal and opposite forces acting on a body such that in between the two forces whose magnitude is same but directions are different, opposite directions, okay, not different, opposite directions, there is a perpendicular distance. So two equal and opposing forces, two equal and opposite forces acting on a body such that between the two forces we have some perpendicular distance, we call that as a couple. See, this is a very important principle, or here we can at least get an idea of our uh, of our earlier definitions of the definitions of equilibrium that we have been giving in the lower class. In our lower class, we have been defining we have been saying that a body is said to be in rest, okay, if the summation of all the forces acting on the body is equal to zero. If the resultant of all the forces acting on the body is equal to zero, then we say the body is in equilibrium, okay? Or that isn't that certainly is a case of equilibrium. One of the condition for equilibrium is that summation of all the forces acting on the body should be equal to zero. But look here, if you see, if you add up the two forces, you have one force acting in this direction, another force acting in this direction. The resultant of these two forces equal to zero, okay? So the resultant of these two forces is equal to zero, but the body will not be at rest, okay? The rest in the body is not possible. So this is a very important condition that actually, enhances or lays stress or exaggerates that some other condition should be there apart from summation of vector summation of all forces equal to zero. There should be some another condition, there should be some other condition that defines the equilibrium of a body. It is, as is a case over here, or we will see the cases in the coming examples, that the resultant sum of the forces will be equal to zero. The resultant sum of the forces will be equal to zero, but the body will not be at rest, as is the case in case of a couple. So for a body to be at rest, it's not only that the summation of forces should be zero, but the summation of all the moments should also be equal to zero, okay? So this is the second condition of equilibrium, and the questions on this will be doing in the next chapters. So this is a very important thing that we are learning from here, that for a body to be in equilibrium, that summation of all the forces, if the summation of all forces is equal to zero, it does not guarantee us, it does not, it does not suffice that the body is in equilibrium as long as the summation of all the moments acting on the body is also equal to zero. So these are the two conditions that must be satisfied by a body for the body to be in equilibrium. Now we are returning back. As far as the couple is concerned, when we have a body such that on a body we have two equal and opposing forces acting such that in between the two forces there is a perpendicular distance, we can simply say that this body is under the influence of what we call as couple. Now, as far as the couple is concerned, how do we measure the couple? That's very important. As far as the measurement of couple is concerned, we have, for example, let's treat this to be a rigid body. Let's say we have a rigid body, and this rigid body is over here. Okay. Now, this rigid body is being acted upon by two forces, force F and force F. The magnitude of two forces is same, but their directions are different. And the perpendicular vector between the two forces is radius vector r. Okay, so this is very important that we do it like uh, we have a rigid body. In this rigid body, we are defining 2 points. We are defining point B and point A, and at point B we are having force F acting. At point A we are having force F is acting, such that the two forces have the same magnitude, but their directions are different, opposite. Okay, and in between the two forces, let's suppose that we have a radius vector r. Okay, now we want to measure the couple, we want to give the definition of the couple. Okay, see what we do. We define a point O. Okay, let's suppose we have a point O. From point O, draw a radius vector to the line of action of force F. Okay, since we have force F acting in this direction at point B, from point O we define a radius vector RB to the line of action of force F. In the same way, A is an arbitrarily drawn point. From point O, we draw one more radius vector to the force minus F, to the line of action of the force minus F. And we say let the radius vector be RA. Now we have drawn two radii, or we have two radius vectors. From point O, we have a radius vector RA, we have a radius vector RA, we have radius vector RA, we have radius vector RB. And in the meantime, we also have a radius vector from point A to point B. So if we can write these vectors as, so we have drawn a radius vector from point A, from point O to point A. We have drawn a radius vector from point O to point B. And we also have a radius vector. We have also drawn a radius vector from point A to point B. Okay. So now, by the triangle law of vectors, by the triangle law of vectors, we can write, by the triangle law of vectors, we can write R, we can write by the triangle law of vectors, RB, radius vector RB, by triangle law of vectors, we can write RB is equal to RA plus RA plus RAB, RA plus RAB. This is how we can write it. Okay, so RA, this is by the triangle law of vectors. Now see, in order to measure the couple of the forces, equal and opposite forces, acting on a rigid body at point A and B, having radius vector RA and RB, and having radius vector R in between them, in order to measure the couple, first of all, we measure the moment of force F about point O. Then we measure the moment of force minus F about point O. We vectorically add the two moments, that gives us the total moment of total moment by these forces, the total or the resultant moment by the two forces, and that resultant moment is what we essentially call as the couple. Now the moment or created by force acting at point B about point O is equal to, so we'll write the moment because of force F, the moment because of, or I will write, I will superscript it, the moment because of force F, I will write it, the moment because of force F about point O is equal to the radius vector RB, the definition that we have already discussed. It is RB, it's RB cross F. That's how it goes. And again, the moment because of minus F about point O, the moment because of force minus F about point O will be equal the radius vector, that is RA cross minus F. Okay, the total moment because of these two equal and opposite forces is what we call as a couple. We define couple as M is equal to couple is equal the summation of the two. Okay, the resultant of the two moments, the resultant moment created by equal and opposite forces acting on a body is what we define as a couple. So that will be equal RB multiplied cross product with F plus RA cross product with minus F. That is simply that we can write as RB. This is the property of the vectors. We can write A cross B plus C cross A can be written as this. The property can be this. With the help of the property, we can write this as this is RB vector minus RA vector, its cross product with force F. Okay, because we know A plus B cross C is A cross C plus B cross C. Okay, so that's equal. Now use the triangle law of vectors, that is RB minus RE. From this we can write, we know from this RB minus RE can be written as, we can write from this RB minus RA. RB minus RA is equal to RAB. That is, we can write this is RAB. This is RAB cross F. Okay, so this is RAB cross F. That's, I can write it here also, that as far as the moment is concerned, the couple is concerned, that's equal to RAB. That's equal to RAB cross. Okay, so this is this RAB cross F is what we call as, this RAB cross F is what is known as the couple, or the moment of the couple. This is called the moment of the couple. So moment of the couple, see, in order to find the moment of the couple, what we have to do, the question is now easy. In order to find, like in this case, we are given, sorry, we are given that we are having two forces, force F and force minus F, acting on the rigid body, such that between the two lines of actions of the forces, we are having the radius vector drawn from A to B. Now, how much is the couple? You don't have to do anything, but you have to, first of all, identify the vector between the two forces, call that vector as RAB, okay, and take its cross product with one of the forces, that is F. That will give you the, that will give us the moment of the couple. Okay, so moment of the couple is the radius vector between the two forces, that is R cross F. Okay, so now when you are using this definition of the moment of a couple RAB cross F, so a moment of the couple is independent of this point A, because RAB, okay, let's talk about it later on, because we'll be calling the moment of a couple as a free vector. Let's discuss that later on. By the time, hang on for some time, as before that, let me explain a few more definitions. Let's go to a few more definitions, and then onwards, let's see what we understand by the free vector. Now, as far as now, again, as yesterday we had the scalar formulation as well as the vector formulation, I'm not happy with this content of the book, as it's giving the scalar formulation, the vector formulation. My mode is like, I believe that students should be in a position to use the formulae themselves and uh, reach to the conclusions or the corollaries of scalar formulations themselves. What I mean is, you try to use this formula, okay? You use this formula in the coming up questions, automatically you should be in a position to derive these types of formulations yourself, okay? In spite of exaggerating over the definitions here, I would like that you solve yourself these scalar formulations, okay? Or you reach to them yourself once you're using these vector formulations, okay? Anyways, uh, as we'll be doing doing this in the coming up questions, still I need to tell you about this scalar formulation. As far as the scalar formulation is concerned, let's suppose, let me open up this. Let's open up this R cross F. So this is R is a vector, F is a vector, the cross product two vectors is a vector, okay? And that vector will be in a direction perpendicular to plane containing R and F, okay? Now let from this definition, let me calculate the magnitude of this moment. Magnitude of moment will be magnitude of R, magnitude of F, and the sine of smallest angle between R and F. Let me call that angle as theta. That is the smallest angle between R and F. Let me call that angle as angle theta. Now let's suppose that this radius vector is perpendicular between the two forces, okay? So as is here, it is perpendicular. So if we are drawing the radius vector from point A to point B, how much angle is being subtended by, how much is the angle between this F and between the F and the radius vector? How much is the angle? I mean to say that if the radius vector is in the form is such that it subtends an angle of 90 degree with the forces, it's perpendicular to both the forces, then essentially our theta in this case will be 90. When we substitute sine 90, that's equal to 1. So moment of the couple becomes equal to R into F. What is R? R is the perpendicular distance between the two forces. And let's call that perpendicular distance between the two forces as D. So it will be D multiplied by F. So it is D multiplied by F. So as far as the D is concerned, D is the force arm, okay? So it means if you have two forces, if you have two equal and opposite forces such that the perpendicular distance between the two forces is D. If you are asked what is the moment of the couple, you will write the moment of the couple is F into D, okay? So the moment of the couple is simply F into D. F is the magnitude of force, D is the perpendicular distance between the two forces. Since you are writing F in terms of its magnitude, D in terms of its magnitude, therefore this formulation becomes the scalar formulation. But if you are using this formulation, where you are using R in terms of its magnitude and direction, you are using F in terms of its magnitude and direction, then this formulation is called the vector formulation, okay? So now let's go to the problems and try to solve few questions so that we understand what we mean by the moment of a couple. Like, let me take up this solved example here. The solved example is, it says, it is like, the solved example says, okay, so let's return back. So I was talking about this problem. Uh, Look at this question. It says, determine the resultant couple moment of the three couples acting on the plate. So we have a plate. On this plate, we're having three couples acting. We're having couple F1, and this is a force of 200 pound acting in this direction. And we are having a force of 200 pound acting in the opposite direction of this. So this and this constitutes one couple. This force and this force constitutes one more couple, and this force of 450 pounds with this force of 450 pounds constitutes one more couple. So if we look overall, so how many couples are there? So we have couple because of this. This is one couple, this and this forms couple pair one, or we say couple one. This and this forms couple two, and this and this forms couple three. So we have one couple, two couple, and three couple. We have to find the resultant couple. Which vary. Use the scalar formulation. The couple because of this F1 pair will be force, that is 200 pound, multiplied by the perpendicular distance between them, that is 4 feet. So we'll write that the moment because of this 200 pound force will be 200 pound multiplied by the perpendicular distance of 4 feet, that is equal to 400 multiplied by 200 is 800. So it is 800 pound feet, okay? But be careful about the signs. What is this F and this F trying to do? Okay, this F and this F, if you put your one hand here and try to move this, try to apply force in this direction, put your another hand and apply force in this direction, then you will see that the effect, just try to realize that the effect will be, it will try to move this entire system in the clockwise direction. Okay, just assume this to be a piece of paper. You keep your hand here, you keep another hand here, and try to move your hand as you are rotating your steering wheel of the car. You'll find it's trying to rotate it clockwise. It's you. And by the way, throughout the course we'll be taking as clockwise couples will be taking as negative and anti-clockwise as positive. Same as now we have force of F3 and F3. So it is 300 multiplied by 5, that is 1500 pound feet, and it's again trying to rotate it clockwise, so it will be negative. That's why he has given it negative here, and it has been given as negative. And look at the force F2 and this F2, 450 pound force. It's trying to rotate it in which direction? It's trying to rotate it in the effect will be in the rotation along the anti-clockwise direction. That's why it has been given as positive. Okay, so just multiply and add them. The resultant moment will be 950, and it's minus means the overall effect of these couples will be rotating it in the clockwise direction. Okay, the resultant couple is 950 50 pounds. Okay, so similarly, solve this problem yourself today, and tomorrow I will be showing you this problem. Okay, if you have any doubt, you can please quickly ask me the questions. Okay, Asham, you have any question? Anybody else having any question? Yes.
सर मुझे एक क्वेश्चन था सर, जो ये मूवमेंट होती है ना सर, इसकी डायरेक्शन हम राइट हैंड रूल से निकाल सकते हैं?
हाँ, निकाल सकते हैं। देखिए कैसे।
सर हाँ सर,